So you have in front of you a table of random digits. Okay, this is called a random digit table. You can use this for your homework, and I was going to show you how to use it. This is like yours to mark on, so don't lose it. That's why I wanted to print you one, so you had one to like write on as you're doing homework, because you can't write on the one in the back of your book, and most of you don't even open up your books. This chapter, we're going to be doing most of our assignments by hand. Okay, most of it will be by hand. Tonight's assignment is on Pearson, but the rest of them will be writing them down. Okay, and so let's get started talking about randomness. Random. An event is random if we know the possible outcomes, but not what did or will happen. Random does not necessarily mean that all the outcomes are equally likely. We are going to be doing simulations. Simulations model random events by using random numbers to specify event outcomes with relative frequencies that correspond to true real-world relative frequencies that we're trying to model. For example, if I want to model flipping a coin 500 times, I probably don't actually want to flip a coin 500 times and count how many heads. That seems daunting, right? Yeah. But we can very quickly, with our calculator, simulate that by using the numbers 0 and 1. And we're going to do that. An outcome is the individual result of a simulated component of a simulation. So the outcome is one flip of the tail, or flip of the coin. Did I get heads or tails? A trial is a sequence of events. So one trial is, I want to see how many times I have to flip the coin to get 5 heads. Once I have 5 heads, that's the end of my trial. I want to simulate shooting free throws. I want to see how many tries it takes to get 5 free throws in. The end of getting that 5 is the end of my trial. Each individual outcome is, did I make the free throw or not? So we have steps we're going to follow for performing simulations. Okay. The first thing we're going to do is identify the component we are trying to repeat. Are we flipping a coin? Are we buying a box of cereal and getting the prize out of it? Are we shooting free throws? Are we taking the DMV test to get our learner's permit? Simulations are used a lot. Large-scale simulations where they use computer programs to do millions of simulations to kind of predict what they think might happen. You won't have to do more than 20 simulations, 20 trials. Okay. And then on the AP exam, if you're given one of these questions, they usually ask you to perform 3. Although it's not a very good representation of what's going to happen, it tells us if you understand what you're doing. Right? Obviously, we don't want you to spend the time on a test to do 300 trials or even 20 trials. Take some time. The next thing we'll do is explain how we model the outcome, and then explain how we will simulate the trial. We normally assign digits to, right, the digits of a number. Now we might use 1 digit at a time. Maybe we're using 2-digit numbers. To be heads or tails. To be, I made the shot, I didn't make the shot. I got the red spoon, or I got the Toy Story spoon, or the Frozen spoon out of the bottom of that Kellogg's Frosted Flakes. Explain how you're going to do that. State what your response variable is. Your response variable is, what is my calculating at the end? Do I want to know percentage of time I got the frozen spoon? Okay, I mean, we had some knockdown dragouts over frozen spoons in my household, right? I mean, what? You know, like a little, you know, you buy a box of cereal and they give you like a collector's spoon? No? Yeah, some of you say yeah, right? And one of them was like Frozen, and one was Toy Story, and one was like, my kids didn't want Toy Story, they wanted the Frozen spoon, right? I mean, there were girls. Frozen was big for them at their age, right? I mean, I guess for you guys, it was pretty big too. So our response variable, is it a percentage or is it an average? We state what we're calculating, and then we do the trials. Analyzing the response variable is calculating that percentage or calculating that average, and then what is our conclusion? Based on my simulation, this is what I think would happen. Just like our model predicts was a very important part of our interpretation of slope and y-intercept, based on our simulation is very important in our conclusion here because it's going to be different for every single one of you. Everybody's answers should be different because everybody ends up setting it up totally differently. I can even give you the same set of random digits to perform your simulations on, and you guys will find 10 different ways to perform that simulation. So I have to go through my calculator and figure out if you did that correctly. Okay, so here is our first simulation we're going to do. Suppose someone hands you a coin and tells you it's biased towards landing on heads. Here is an unfair coin. It lands on heads more than tails. Would you be skeptical?
Yes.
Probably. What would you do? What would you do to prove it? To prove he was wrong or he was right?
Would you flip it like that's not 10 times?
Sure. Flip it out of 10 times. How many heads would it take to convince you it was unfair?
So,
Over 50.
Over 50?
Yeah, we're 50%.
So you get 6 heads out of 10, you're convinced it's not fair.
No, I would say more than okay, so more than 50. Like it's 70.
If I'm winning this,
I would say 70.
I would say 95.
Okay, so let's not think 7 out of 10, because 10 trials can go anyway, right?
Maybe
These are random events.
Okay, out of 10.
Out of 100, I want you to write a number down on this slide,
70.
on your notes. What is your number that would convince you that a coin was not fair? A number of heads out of 100 that would convince you this is not a fair coin.
That there's not really a number that was
Nothing can convince you.
I feel like it's just like, it is what it is.
Heads
You know?
would not convince you that it was unfair.
That's unbelievable.
I don't think it's unfair. I still think a coin is just 50-50.
Okay. Okay.
The odds that you flip the coin 100 times and
100 times
get heads
100 times?
100 times in a row
So 50.
Yeah.
doesn't seem that likely. Probably like
I have a coin right here.
1 out of 1 million.
Okay.
I really hope I have 40. I do not have a quarter. Yes, I do.
Okay, so for our class, we had 60 was the lowest. We had someone choose 70, and then we had a bunch of 75s, a bunch of 80s, 5s. Okay, and then we had a 90, and we had someone say 100. Okay, so how can we test this? Without actually we have to do a simulation, but you have to do a simulation more than once. So you have to do a flip of a coin 100 times, right? You have to flip the coin 100 times, 100 times to get a good simulation. So you need to do 100 flips of the coin 100 times. The problem with using the coin flipping app in the calculator, which it does 1,000 flips, but I want to do 100 hundreds, right? I want to do 100 trials of 100.
Then it would be out of 1,000.
Right.
Do that.
Yeah, then you have to do 1,000 times, right? The more we do, the closer it's going to be towards a 50% ratio. Okay, so We said it would convince us, let's say about 75, that it's unfair. Where do we draw the line between reasonable behavior and an outcome so strange we think it proves something wrong? That's really what statistics ends up being about. Where is that line where we think, no, this is not natural, something's causing this change? And, oh, that's just normal variation. So, in your calculators, get your calculators out. If you are not getting your calculator out and following along with me, most of the time you're confused. Get the calculator out and work with me. So this is how we're going to set up our trials. If we each do it 3 times, we have almost 100 sets of data, right?
Yep.
Right. I mean, there's 35 of them, 30 some of us. Okay. So we are going to call, this is set up wrong, so fix this. 0 tails, because we're counting how many heads, and 1 heads. Assigning numbers to represent your outcomes, heads or tails. We're just going to use 0 and 1. Okay. We're going to do it 5 times. If I go into my calculator, hit the math button. Math. Hold on, let me get a video going here. Nope. Sorry. We are not using the coin flipper. We're going to go to our math button. We are going to go over to prob, which stands for probability.
Then we go R and int.
And we're going to go to rand int, which stands for random integer. Rand norm is a random normal number from the normal model. Rand bin is a random binary, 0 and 1. And rand int no repeat is if I don't want a repetition. So I'm okay with repeats because I'm doing heads and tails, right? If I'm selecting 4 people from the class and the winners get
Ice cream.
the, what were those called? The crock thingies? Yeah, the gibbets. I don't want repeats, right? I don't want repeats if I'm giving out prizes, unless I want to give it to someone twice. So I'm going to hold rand int. My lower number is 1. My upper is going to be 0.
Why is it like,
Lower is 0, upper is 1.
My lower is 0, my upper is 1.
Okay.
It's Monday.
that ends 100.
I did.
Did you have enough?
No, not for a Monday, right? My alarm went off at 4:30 this morning, so.
Why? Do you
So-
judge yourself?
Because there's no time after school. So, okay, so let's just do a flip of the coin 5 times. Let's just see what we get. Here I get 1 0 1 0 0. So how many heads did I get?
Oh, I got 1 1 0
Got 2.
0 0 1
Heads or ones, right?
Wait, Mike, what did you get?
Are we all gonna get something
We all gonna get something
Okay, everybody should be getting something different. Now, some of you may have gotten the exact same thing. And it's possible that that happened because your calculators are brand new. The random generators in calculators and computers are not truly random. They're pseudo-random. They use an algorithm, and they start with a point called a seed point. Well, all of your calculators are starting with the same seeded value if it's just out of the package. If you have a calculator that was used last year, we reseeded the calculator to the last user's birthday. So we're going to seed everybody's calculator to your birthday so everybody gets different values. Anybody have the same birthdays in here? Anybody know if you have the same birthday? Okay, we are telling a starting point. The seed is where your computer program starts the random generation. So your calculator, if you get it just out of the package, starts at 0. And then it does 1, and then it does 2, and then it does 3. And it puts it into some kind of equation and spits out random, pseudo-random numbers. So that's why some of us are getting all the same answers. Or if your calculator got reset. So the seed is where your, because the seed is where a plant starts, right? So that's why they call it a seed. So you're going to type in your birth date just like you do in Canvas, right? Your password, right? So mine is 0302.
Your birthday's in March?
I don't know if I want to put this part in. 1979.
Are you a Pisces?
You just turned like 21.
I am a Pisces.
I was gonna say people born after my parents, but that's the same.
Yeah.
That's okay.
Okay, everybody put their birthday in?
Yeah.
Okay, then you're going to hit the store button, S-T-O, where you're going to stow stuff.
Stove.
So store, and it puts a little arrow. It's right above on.
Wait, you all said a lot of things over.
Store is right above on.
Oh.
Store is right here above on. Stow. So everything's abbreviated. And then you're going to go into math, over to probability, and select rand. Okay, math, probability, rand, and then hit enter. It's just going to repeat that number, but now you've reseated the calculator to start with this number, and then it'll continue to increase it by 1 as it does your random number generation. So you should be getting different numbers unless you reseed it to the same thing. So if I, on a test, said, okay, seed your calculator to this, right, then everybody should be getting the same random numbers because you have the same starting point. Okay. All right, so let's do that again. Do second enter, second enter. Do it twice, and that brought this back up without having to go into the menu.
Whoa.
Okay, that's gonna come in handy.
Yes, it is. That was sick.
Brings up your old entries, and then hit enter again.
I got one.
I got heads, tails, tails, heads, tails. That's what this means. Everybody see that that's what that means now.
0, 0, 0, 0, 0.
Okay.
All zeros.
Heads, tails, tails, heads, tails. So I got 2. Let's do it again. Hit second enter, but this time do 10. Change the 5 to 10 this time.
That's cool. That's cool.
How many do you get?
Damn, I got
I
tails in a row.
got 10, 1, 2, 3, 4,
Got
5.
3 tails. Wait, no, 3 heads. 3 heads.
I had eight tails and 2 heads.
I got 5 and 5.
I got 7, 3, 7, 3.
Okay. I just hit second enter, and then I went over,
I think there's
use the arrow to go over to the 5, and then I typed 10 over it.
Oh, gotcha.
Okay. Now I want to do 100. Change it to 100. Here's the problem with the 100. Counting it, right?
Yeah.
What if I close the parentheses? Okay, close the parentheses. Hit store.
Stove.
And then tell it to put it in a list. List 1. That'll make it easier to count, right?
Yeah.
I just hit close the parentheses on 100.
Stove.
I hit the store button. And then I said list 1. I'm saying generate for me 100 numbers between 0 and 1 and put it in the list. I was just telling the calculator, after you do it, put it in the list. So I'm going to hit enter. And I have a choice of either scrolling through this. Go to your list. What do you see? 1s and 0s in my list 1. So that's easier to count, right? No, I got a shortcut for that too. Okay, we still don't really want to do that many times, right?
Not at all.
So would you say if I add all the numbers in this list, the sum would be the number of heads?
Yeah. Yes. Yeah.
If I added up all these numbers, is the sum the number of heads?
Yeah.
Yeah, because heads are 1 and tails are 0, right? So if I add up a bunch of, and I get 65, that means I had 65 1s and 35 0s. Okay, so go back second mode takes you back to this screen. We're back at this screen, second quit.
Yeah, back.
Go up. Teachers.
I'm going to ask it for a sum. Hold on, I got to find it. Sum. Okay. You're going to go second stat. Above it says list. Go over to math and find sum. Second list, over to math, find sum. Did you find it? Okay, hit enter. Is there something else in front of it or around it? Just hit second quit again. Maybe clear and try again. We're going to tell it what to add up in a second.
They still doing error.
Okay, hold on. Okay, I gotta get a new video. Hold on. My hand gets tired of holding this up.
Yeah, you have it holding it up first.
You got 4 arms and biceps.
Okay, now we're gonna go back to math. Back over to probability, down to rand int. 0, 1, 100. Paste.
Now,
Math. Over, now you can hit enter. Math, probability.
52.
49, baby.
I got 50.
2.
I got 53.
So you can do this lots of times, right? I can do it again. Just hit enter again. I got 52. Enter again. I got 40. Ooh, 40 is pretty low.
45, 57, 44, 47, 45, 50.
Okay. We have... Okay. So, what do you notice?
166. It is unimodal.
It is unimodal. What else? It's symmetric. It's what? There is an outlier of 66. What do you notice about the difference of what we expected, right? So we said it would take pretty much 75 or more heads to convince us this was an unfair coin. But without the outlier, you're really in this area here for the majority of the data, right? Between 40 and 60. It's probably centered at about 50. Is that surprising?
No.
That this is centered at 50% heads? No? Not surprising? And then we have this little outlier out here. But looking at this now, does that change how many heads it would take to convince you that it was unfair? This was at least 90 trials of 100 tosses. Does that change your number? From 75, 80 to be like, really anything greater than 65 is pretty unusual, right? We're going to learn later in chapter 17 that the standard deviation of this distribution is 5.
Really?
So the standard deviation is 5, which means anything above 65 heads has what percent chance of happening? 0.15% is usually above 3% standard deviations. So anything above 65 is really rare, which means even 60, only 2.5% of the time do we get more than 60 heads out of 100. Okay, so this is what simulations can do for us. They can help us model situations without actually having to do the situation. If I want to go and I know somebody's free throw percentage, instead of actually having them shoot free throws over and over and over again, we can do a simulation. And that takes out some of those factors like fatigue that would cause them to miss more free throws. The farther you do, the longer you do these trials with them, the more free throws they're going to miss because they're tired now. You just made them shoot 100 free throws.
Does the calculator have a free throw?
No, but we are going to sim free throws. We are going to talk about a basketball player with an 80% free throw success rate. How can we use random numbers to simulate whether or not she makes a foul shot? How many might she be able to make in a row without missing? Okay. Describe the waiting time simulation. Okay, a waiting time simulation means how many until I miss, or I want to count until I get my first failure. We're describing most things as success, failure. Success is I got what I wanted. Failure is I didn't get what I wanted, right? So success here is she makes the free throw. Failure is she did not. So waiting time simulation is how many until I stop doing something. Of how she's going to shoot free throws until she misses, and we're going to count the number of successes. Okay, so we're going to go through the steps of the simulation. What are we simulating? Free throws. We are simulating free throws. Now, she has an 80% free throw percentage. That means she makes it 80% of the time. When I'm doing simulations, I can choose to use one digit at a time. How many numbers are there from 0 to 9? 10 digits, right? If you include 0. So everything has to start at 0 because we can't go from 1 to 10. We go from 1 digit to 2 digits and that messes everything up. So we shift everything back to 0. From 0 to 9, there's 10 digits. How many of those numbers need to represent that she makes the free throw if she has an 80% free throw percentage?
8.
8. 8 out of 10. 80%, right? So other options are to use the numbers from 0 to 99, right? When I have even percentages, 80, 70, 60, multiples of 10, I should be using 0 to 9, one digit. But if I said, and later on we're going to do, what if it's 73%? Now I have to use 100 numbers from 00 to 99. And I need 80% of them to be making the shot. So if I'm starting at 0, from 0 to what number is going to mean she makes the shot if I need 8 numbers? 0 to 7, right? That's 8 numbers. 0, 1, 2, 3, 4, 5, 6, 7 is 8 numbers. So that's a makes the shot. So we're going to say let 0 to 7 be makes the shot. And 8 and 9 mean what? She misses. Okay, so this is 2. Explain how we will model the outcome. Okay. You need to get in the habit of writing this all out. On the quiz, I will be checking each of these components. Okay. So, step 3, explain how we will simulate the trial. So because we just did a trial with the calculator, we're going to use the calculator. Okay. And that's probably what you'll do for most of your tests. Most of your homework. But on tests and the AP exam, they use a random digit table. So you have to know how to use the random digit table because they give everybody the same set of random digits. So then there's less answers, right? If you're allowed to use your calculator, then every single one of you gets a different set of random numbers, and therefore you get different results, which makes it very hard to grade. If I give you a set of random digits, then you come up with 4 or 5 different ways, so there's 4 or 5 possible answers. Okay? So we're going to use randint. Zero comma 9. We're going to count shots made until the first missed. Okay, so we're going to keep going until we get an 8 or a 9, which means she missed. Right? We're trying to figure out how many in a row can she make. That's what explain how you will simulate the trial mean. Now, if we were doing a random digit table, we would say use a random digit table 1 digit at a time, counting the shots made until the first miss. That's the end of a trial, the first miss. 4, state the response variable. So the number of successes, so we're going to look at the average number of shots made before she misses. If I'm just counting up something, if I'm going to be counting, then my response variable is an average. If I'm saying like yes, no, we did this, we didn't, then we're looking at percentages. Now let's run our trials. At least 10 trials. The book usually tells you how many. If it doesn't, 10 is the minimum. Yes, any questions? Okay, so in your calculator.
She said,
Okay, so I'm going to go math, probability, randint, 0 to 9. I want 1 at a time. You can generate 10 and then go through those if you wanted. I'm just going to do 1 at a time. So I got made it. That's 3. That's 4. These numbers, then it's 0. And that's the end of your trial if she misses the first one.
0.
Okay, so I want you to write down your trials. I don't want to do 20 myself. If we all do 1, then we can move on, right? Okay, so everybody do how many till she misses? So any number between 0 and 7 represents she makes it. So if I get an 8 or a 9, that's the end of my trial. So I'm at 4, 5, 6, 7, 8. There we go. She missed it on 8. That means she had 7 makes. Okay, don't count your miss, right? Because I'm counting how many she made, right? So then yours is 0. Okay, so you are going to, this is really important. You don't need to write down what your calculator gave you over and over and over again. You need to write down the fact that she made 7. Comma. And so what's my next trial? Okay, you don't have to write down what the calculator gave you. You're just calculating that up, and once the trial's over, you're writing down your results of the trial. Okay? Yeah, so you would do it 10 times. We're going to do it all once. Okay, Michael, what did you get?
I got 8, the first one.
8. Dylan, what'd you get? 0?
Yeah.
Georgia?
I got 8.
4. I got 4.
You got 4? Aya?
I don't know.
You don't know? What'd you get? 0? 9? Brayden, what'd you get?
The first one, 1.
1? Kennedy? It's your first trial? 1? What'd you get? 1? 0? 1?
8 or 9. 0. She missed. 7.
What'd we get? 10. What'd you say, 1?
1.
4.
6. 0.
1.
What did you get, Brianna?
I don't know, this doesn't look like 80% to me.
15, wow.
That's a lot of frequency.
Do you have a number?
I didn't even know 15
What?
was an option.
Okay, that's enough. We got enough, right? So number 6 is analyze your response variable. That means calculate this average. So add this all up and divide by how many there are. That's our response variable. What, on average, how many did she make in a row?
We have to do your numbers.
If you did it 10 times, you can do your numbers. That's fine. 1, 2.
Somebody made all 10 times.
Someone made it 15 times. 95.
You got 95, I got 96.
I
I may have added it up wrong. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I got 96 out of 27-ish. I may or may not have added it up wrong, right. So on average, and so our conclusion, this is what our conclusion looks like. Based on our simulation, we expect her to make an average of 3.55 shots before she misses. Okay. So on your homework, if you're using your calculator, everybody's getting different answers. But we're answering the same way based on my simulation, right? Because your simulation is giving a different answer than the person next to you's simulation. This is what we expect. Her to make an average. We calculated an average. Averages are allowed to be percentages, even though you can't make half a free throw. This is her average. That's allowed to be a percentage, or I mean a decimal. Okay, good. Okay, so your homework tonight is on Pearson. It's really about simulations in general, how to set them up. You won't have to perform a full one by hand until tomorrow night. Okay, so again, we are changing the free throw percentage to 77%, and we want to know how many shots she's going to make out of 5. So our component is shooting free throws. 77 of the 100 numbers have to represent making the free throw, so it's 0 to 76. And then the rest, 77 and 99, means she missed. We're going to use the random digit table, 2 digits at a time. Okay, that means we're grouping them. When we get to here, this is 19 and 22 and 39. Okay, and then we're going to mark up our random digit table. It's going to be real easy on the top line. It's going to be less easy on the lower lines because they're not spaced out very well for us. Normally, when you see a random digit set of random digits on a quiz or the AP exam, they give you space to kind of write in between what you're doing. Okay, you need to show on the random digit table how you are doing each trial. So you have to mark it up, and that's what I'm going to show you right now. So our random variable is the average number of shots made out of 5 attempts. So we're going to do 5 shots. Okay, she made it or missed it. So we're going to do a check if she made it. We're going to do an X if she missed it. Okay. So for the first number is 19. Is that a make or a miss? That's a make. So we would put a check. The second shot is a 22. Is that a make or a miss? That's a make. Now remember, the space is just to keep our eyes from getting super fatigued. So this next number is 39. Make or miss? Make. 50. Make. Remember that 77 to 99 is a miss. and 34 is a make. We're going to draw a vertical line because that's the,
95.
no, 39. It's not 95, it's 39. So she has 5 makes, right? So we're going to draw a vertical line showing that our trial has ended, and we're going to write down how many did she make? 5. And then you can write on your homework paper. You do not have to send me a picture of your random digit table from the homework, right? But that's why I gave you the paper one, so you can physically write on it, okay? And then all I need to see in the homework is your list of results, okay?
Does it matter when we start on the random digit table?
No, you can start with any line you want. I recommend, though, for the notes, you start with the line I'm using so you can follow along, right? Okay, so now we don't need to start a new line for our next trial. We're going to pick up at the end of the last trial. So that was one trial. My second trial, what's my first number?
5.
What? 20 times. My first number is 5. What's that? A make. 75. Make. 62. 87. Miss. 13. Make. And that's the end of my second trial. And that's 4 makes. Okay, so my next one is 4. So what do we get for the first and the third trial here? 96 is a miss. 40 is a make. 91 is a miss. 25 is a make. 31 is a make. That was 5 shots. My trial's over. I had 3. Okay. And then do it again. 42 is a make. 54 is a make. 48 is a make. 28 is a make. 53 is a make. That's the end. She got 5. Okay. 20 times. Okay. 20 trials. Each of the numbers represent an outcome. I need 20 sets of 5. Okay. 20 is a good number that helps us do enough trials to where we get a good model of simulation. Real simulations are done with tens of thousands to a million trials by the computers. On the AP test, they usually only ask you to do 3 trials because we know that it's going to take time, right? So you do maybe 3 trials on a quiz or the AP exam, but a real simulation needs to have lots of trials so that you balance out any of the anomalies. 5 in a row, if that's an anomaly, or 0, that would be an anomaly. So it kind of needs to balance out.
At the end, we just take the average? Or?
Yes, at the end we'll average all of our values. Okay? All right, so let's keep going. We'll do 10 for the notes, just because, but your homework will tell you how many trials to run. Okay? All right, so our first one we're on line 102. Do not use the line number for your random digits. 73 is a make. 67 is a make. 64 is a make. 71 is a make. 50 is a make. End of my trial. That was again 5. 99, miss. 40, make. 00, make. 19, 27, make. So we're at, that was 4, right? 27, 75, 44, 26, 48, 5 again. 82, miss. 42, make. 53, make. 62, make. 90, miss. So on that trial, it was only 3. See how I'm writing on my random digit table? You will be expected and graded on how you write on your random digit table. Part of that is because everybody generally sets up their numbers differently. There's always one person that decides that they're going to make 0 to 22 be missing it, and then 23 to 99 making it. Just to be different, they switch it up and put the missing it at the front of the set of numbers. And so I have to be able to look at your random digits and make sure you used your numbers correctly for the way you set up your random digits. Okay, so part of showing your work is marking up those random digits 10 times. Okay, and like I said, on a quiz you're only going to do 3. It's not going to give you a very good estimation, but it tells us if you know what you're doing or not. Okay, all right, so let's get the last 2 done. 45 make, 46 make, 77 is a miss. 70 is a make. Wait, no, it's not 70. It's 17 and 9. So that's 4. 77 is a miss. 77 and 99 was a miss. And then 77 is a miss. 55 is a make. 80 is a miss. 0, make, 0, 0, and 95 miss. So that was only 2. Okay, so that should be 10. Okay, so this is our 10 trials, and that's what your random digit table should look like. Okay, so then if you're using the random digit table for homework, I would probably start the next problem at 105, right? And if you are working with someone else, use the same line on your random digit table so you can compare to see if you're doing it right. If you're using different lines, you're getting different answers. If you're using the calculators, you're also getting different answers. Okay, so step 6 is to analyze my response variable, which means, this step 5, run your trials, calculate my average. So calculate your average. What is it? I got 40 over 10, which is 4. Right? So then we say, based on our simulation, 7 is our conclusion. Based on my simulation or our simulation, I expect her to make an average of 4 out of 5 shots. Now, if my average was 4.1, then I would say an average of 4.1. I do not round my average, okay, unless it's like 0.333333. We round that, but you don't round up to a whole number, okay? Now, I want to show you the difference, how to do the same thing in the calculator, okay? So with the calculator, everything else is the same except for we're going to say, instead of use a random digit table, we're going to use randint 0,99, 5. Counting the number of shots, everything else stays the same. Okay? Randint, when I put in 5 at the end, it says, give me 5 numbers. Well, if I'm doing 5 out of 10 shots, I can ask the calculator to give me 5 at a time, and then I can analyze that. If I'm doing how many till she misses, I kind of have to go 1 at a time, which is what we did yesterday. So in your calculator, where's your Randint button? Math over to probability down to 5. 0, 99, 5. You don't have to do 5. You can do 1 and push enter 5 times, but it certainly is faster to have the calculator give you a set of 5 numbers, right? And then we're going to go to paste and hit enter. So my trial is made it, missed it, made it, made it. Do you see it?
Oh, so you're going to do this 10 times then?
Yes.
Okay.
So for this trial, I had 4. Right? And then I can just hit enter again. Trial number 2, I had 4 again. Made it, missed it. 4 again. Right? Do you see the 4? She missed it with the 98. How many is this one? 28, 26, 9, 70, 99 is a miss. 4 again. Hit it again. There we go. I got all 5. That's 4 again. Here, 87 is a miss, so that's 4 again. That's a 5. Right? There's nothing over 76. There is a 4. There is a 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that makes my 10 trials. You can see how it's tempting to only use the calculator, right? Way faster. But you have to be proficient with using the random digit table because that's how the quiz in the AP exam is going to be set up. Okay?
So the AP exam, we can't use calculator?
You cannot. You have to use the random. You can use a calculator on the AP exam. You cannot do the simulation with the calculator. You have to use the random digits that are given to you. They have to make sure that there's only a certain number of possible answers that come out. If everybody used a calculator, there would be a million different answers for this one problem, and it'd be impossible to grade.
On the AP exam, how many simulations do they include?
It's there's usually a couple of questions within the multiple choice, and then it's a possible free response question. So, okay, so I have 1, 2, 3, 4, 5, 6, 7. So that's 28 in 4s plus 15 divided by 10, obviously is 4.3. Okay, so 43 out of 10, 4.3. Okay, so here's a good example. My conclusion is going to be the same. Based on my simulation, I expect her to make an average of 4.3 out of 5 shots. Okay, my average is allowed to be a decimal. And you can see one simulation gave us 4, and the next simulation gave us 4.3. They're usually around the same number, like somewhere around the same number. You're probably not going to get like 1 for a simulation on this average. Okay, but yeah, you can, but you might get a trial that's 1, right? But it's really unlikely you get the average of all your trials to be 1, right?
On tonight's homework, when we went for a trial, can we just start from any line?
You can start from any line, yeah. And you can go between, like, there's 2 simulations on tonight's homework. So go between using the calculator and using your homework, the random digit table. All right. Let's look at a different situation. A 1-and-1 situation. Can somebody explain that situation to me? In basketball. What is a 1-and-1 situation?
ISO.
Okay.
Isolation.
So they shoot 1. If they make it, they get to try again, right? If they miss the first shot, they're done. They don't get a second attempt. Okay? So the possibilities are 0 points, right? You miss the first shot, you're done. 1 point, you make the first shot, miss the second shot, that's 1 point. Or 2 points, you make the first one, you make the second one. Okay? So in this 1-and-1 situation, she still has a 77% free throw average. So we are shooting a 1-and-1 situation. Same percentages, 0, 0 to 76 is going to be a make. 77 and 99 is going to be a miss. We're going to use a random digit table. You can abbreviate that in RDT, random digit table. How many digits at a time? 2 digits at a time. It's so important when you do this homework to not skip the things that are important to say, because you then forget what you're supposed to say when it comes time to the quiz and the test. You have to say you're using the random digit table and how many digits at a time you're using it. And then what are you going to do? Okay? So if the first number is a make, we look at second number. And count points. If the first number is a miss, the trial is over. Our random response variable is going to be the average points earned in the 1 and 1 situation. So again, we're going to go back and practice this random digit. The calculator part's easy, right? The calculator is 0 to 99. Make it 1 and hit enter. This is the harder part. Okay, it helps if it's not blurry. I'm going to start on, I think, 105. I'm just going to start on 105 because I've already, if I'm actually writing on this like you are, you don't need to erase what you've already done. Use a new set. Okay? So I'm going to go and start with 105, okay? So we're right here.
So when we do our homework, are we going to start from like whatever after we're done?
Yeah, whatever one you after this. Yeah. If you do use a random digit table, you should get all the same answers if you start at the same spot. The back of the book is going to say all the components for setting it up. Answers may vary. It should be around this average. Okay, so let's start the first one. First shot is a miss, so that means trial 1 is 0 points. Okay, trial 1 is over. She missed her first shot. She doesn't get another attempt. Just to leave space in between the problems. The next shot is a 59, which is a make, and a 29, which is a make. So that's 2 points. The next trial, 40 and 7. That's make, 2 points. Once you get good and start recognizing your numbers, it doesn't take that long to use a random digit table. So 69 is a make, but 97 is a miss. So that's 1 point. And you can, and the next one is 19, make, 14, make. End of my trial, 2 points. The next one is 81. That's a miss. Trial's over, 0. Okay. Next one is 60, make, 77 is a miss. So 1 point. Next one is 95. What's that? A miss. 0 points. Okay, is that a 37? 37's a make. 91, miss. So that's 1 point. 17 is a make, 29 is a make. So 2. Okay, is that 10 trials? 2, 4, 6, 8, 10, 11. 11 divided by 10 is 1.1. So based on my simulation, I expect her to score an average of 1.1 points in a 1 and 1 situation.